move this up a bit. There we go. Good afternoon, everybody. How many people have got here today? That's a bit of an angle. I'll sort out that angle first. You don't want to be staring up my nose for the next 3 hours, do you? That's it. Move it up a bit. Right. There we go. That's better, isn't it? Right. Good morning. No, good afternoon, everybody. Good morning if you're in Latin America. Time for the session on advanced NGSI LD operations. One of the things I'm going to try and do today is I'm going to try and get you to do some exercises live whilst I'm having my cup of coffee. Obviously, the best way to try and learn something like FIWARE is to play with it. And we have a series of tutorials and exercises, which I've got on the other screen, I believe. Just a minute. Where's it going? Put it here instead. You'll find that for NGSI LD, the tutorials list is here, this link here. And each tutorial covers one aspect. Obviously, they start from the beginning, but what I thought I'd do about halfway through is I will show you a little demo video, or rather, Key will show it to you so that my machine doesn't fall over. And then I'll leave you to actually try and run that yourselves, because it will combine IoT devices and several FIWARE components all together using temporal interfaces. And temporal interfaces is one of the elements we're going to be covering with advanced operations. For those of you who want to contact me, ask me questions at any point in the future when you understand. My mic is making a weird sound. That's not very good, is it? What sort of weird sound? Is it kind of ticking sound? It stopped. Even better. So, okay, I shouted at it. Yeah, I think the fan on my machine is starting to die. I think FIWARE will need to provide me with a new laptop fairly soon. So if that really starts falling apart, you'll have the fun of this session really falling apart. So stop it. If there are any issues, like you can't see the screen or what have you, put the stuff in the comments. Key will be monitoring the comments and can shout at me saying, "Oi, they can't see it, you can't do it, what have you." But the quicker you stop me doing something stupid, the better. Okay, let's get on with the slide deck. So, useful links. As I said, the NGSI LD tutorials are slowly growing on NGSI LD tutorials read the docs. Each one covering a small part of FIWARE. There's an equivalent for NGSI V2, and indeed, not all of the security tutorials have been moved across to LD as well. As I hopefully explained yesterday, along with Alvaro and Alvaro, security is orthogonal to the data loads you get in FIWARE. So you can use whichever security system you want. So therefore, you can all the security tutorials which are relevant for NGSI V2 are equally relevant for NGSI LD. It's just these various components like your PEP, your PDP, your PAP, APIP, to actually decide what traffic to let through or what traffic to stop because they failed to go through. So you've got all the NGSI LD tutorials, and you've got the FIWARE tutorial to play with and to muck around with and to break and to rebuild. Every time they start, they clear out all the data so that you start from a clean sheet. For those of you who like really dry specifications, but it's the truth, then the obvious place to go is the NGSI LD specifications. 141, that's the 141 link. 151, I think, is the latest. Most brokers are already covering 131 in its entirety. 141, 151, they've got a few extra bits and pieces which might or might not be there. One of which is aggregated temporal endpoints, which I think we'll end up covering later on today. This is the NGSI equivalent of the JSON LD org specification, which was touched upon yesterday. It's in very formal language, but it is the original source of truth. So if you like reading the original source of truth, that's where to go for. For those of you who are more interested in how to get hold of NGSI data and how to manipulate it and how to use it, the next three lines on screen of use. There is a swagger specification for NGSI LD, which means you can actually generate the all the API endpoints. Indeed, I believe that's how the NGSI v2 interactions were originally set up for the tutorial. And there are guidelines on how to create up your NGSI LD models. Now, I'll emphasize again, because it really is fundamental to this whole i4Trust project, setting out what you've got in your world and what the IRIs are for the various attributes is an essential first step if you're doing data-driven first. Now, it's where there are existing data models, such as smart data models, which tends to do domains like smart cities, smart energy, smart water, what have you. Obviously, reuse that or expand on that where possible. Where there are missing domains, so I don't think we've got that much on logistics at the moment. There probably already is a front runner who's already doing the IRIs on this. The case I was looking at was the Ngsi pages. I think I've got the links somewhere. I'll just have a quick look at my history. Just a second. Yeah, here we go. That's the link. So this isn't ours, but this is a different set of data models. Similarly, you've got schema.org. I'll put schema.org in there as well. Or GS1 is the other one which I tend to use. The actual JSON LD from GS1. There are domains out there which have got organizations which have been creating the relevant JSON LD information. Now, we're not about reinventing the wheel here. If there is a relevant domain standard, use it. There's, you know, it's out there. Potentially make a PR request to add it to smart data models so that other people know where to find the original. But you know, use the existing ones out there so that, you know, if you are say doing shipping, for example, you'll find that the UNCFAC address is slightly different to the schema.org address. The schema.org address actually matches the GS1 address and also matches the TM. It matches the smart data models address, and is slightly different to the TM forum address. All of these are saying we're addresses. We're nearly equivalent to. But if your basis is shipping bills, for example, smart ports, then use the industry standard for which has got the various lines of address in it, rather than use the one from schema.org, which is much more generic, and therefore that's the one which most of the smart data models tend to follow. This also gives you an indication of how to extend your models if necessary. If you want to add in, say, additional languages, then again, the Ald specification agrees with this, is that you can have things like same as, which is coming from schema.org, so that you can have relationships between different entities. Final link there, semantic modeling. NGSI LD paper is a bit more informative to work out how to create these in the first place. Okay, let's start looking at stuff in more detail. In NGSI v2, there were a series of headers you could put in to your requests, because NGSI v2 is implicitly multi-tenant, and the equivalents have been added into NGSI LD. Because NGSI LD is not just FIWARE, they didn't want to keep the name FIWARE-something. So they've now got called NGSI ID tenant, and I believe it's NGSI scope or path. I can't remember which at the moment. It's in the most recent update of the specification, not on the ones beforehand. And the idea of adding in a tenant is that if you have that in your request, all that information, the current state of the system, is held in a separate database. So if you have a customer, you can have a customer who, I mean, I'll use farming examples. You've got a farm. You've got a farm. You can have all their cows in one separate database to somebody else's pigs or sheep or whatever. Now, this is not that important necessarily for agri, but for legal reasons, GDPR, when you're talking with people and what have you, you need to be able to ensure that your database is separate from somebody else's data. I mean, it's obviously not a good idea to mix people who shouldn't be in the same system. So this was the reason why it was added back into the NGSI LD specification. We'll see some examples of that when I start demoing later on, but tenant is I would use tenant all the time. I wouldn't use the default tenant, because all you need to do is you have your standard link header, which is saying where your models are, and your standard tenant for whoever's using it, and you just do it for all your requests, and everything's in the same place. But that, if you fail to put this in, it will use the default tenant, and if you start using it and then not using it, you might find, hey, there's no data in my database. There's no data in my context broker. Yeah, because you're looking for it elsewhere. Content type header. Again, this is on our requests. You've got actually now 3 types rather than the 2. You've got application JSON, application LD plus JSON, and application Geo plus JSON. Now, there are GeoJSON is just an output format, but these 2 you can use for full context broker interactions. If you have a content type of application LD plus JSON, you will find the bit in yellow. You will find an at context explicitly in the payload body. Now, you can see there that I've put in FIWARE data models, whatever, plus the core context from Etsy. If you put the content type as just application JSON, then you can't have an at context in your body. It is placed as a link header. Now, if it's placed as a link header and you're talking within a context broker, then it is assumed that the core context will come afterwards. Now, this is useful for broker-to-broker communications, because obviously you don't need to worry about the core context all the time. You just say, this is my world. But it's always my world plus all the other core context stuff. What it does mean is that when you come out of your context brokers and you want to start using this data as JSON LD, then you need to point the @context file to something which also includes the core context if you are using the normalized format. If you're using just key values, fine, it'll work anyway, because key values gets rid of all the stuff on the. Is it really hard to understand the speaker's voice? I don't know. I'm shouting here by my screen. It works very. Voice is loud and clear. Maybe try reconnecting. Right. Am I going to have to sit here and sing a song whilst we wait for various people to reconnect?
No, sometimes it doesn't work well with other browser than Chrome. So maybe just try.
Chrome is probably the one to go for. I'll tell you what. I'll have a quick sip of coffee, clear out my throat.
And for me, for example, I log in by in incognito mode, so it's could help as well.
Yeah, I think AirMeet tends to use Chrome extensively. I'm certainly running Chrome here. Use Firefox, Felix. Okay. I'm really noisy. I'd like to know why I'm really noisy. Was it really noisy yesterday? I hope not. Well, is it yesterday, Monday? It's the same setup. I've got that in there. I've got that in there. I'll just check the wire. Let's see if this will help. That might help. Right, that might help. Well, that's good. So for those of you who've got the constant whirring, I think that is probably, or possibly my fan. If there's a bit of whirring in the background, I can hear that as well, which is annoying, because that's as I said, it's just my machine starting to die on me, I think. Yeah, I mean, I've been working at FIWARE now for the last 3.5, 4 years. It's about time they gave me a new laptop. So yeah, now is that any better? No, it's not, because I can still hear it.
It's getting worse.
We get worse. Loud and clear. Okay. Oh gosh. All right. Well, I'm sorry about this if it's not quite working for you. You can always try running this with subtitles. That's what I tend to do on the recording. Anyway, where were we? Okay, so if you are coming out of context data brokers, and then you're doing, say, a subscription to another microservice, and that other microservice is receiving the data in as key value pairs, for example, rather than normalized NGSI LD JSON, then you'll need to make sure that you have the necessary @context file available. For the normalized, obviously, you'll need both of these elements in there. Linked header is generally preferred for context broker to context broker communications, or in our case, context broker to registrant, because obviously you're going to have some third party over there with their own context broker, because it reduces the size of the payloads, because all it needs to do is to say, okay, all this context data, it's in a file which you've already cached from somewhere over there, so you can get hold of the information, caching it easily enough. You can see at the bottom of the page what the full link header looks like. It's as I said, it's a path to a public server. In all the examples, I'm just using a HTTPD on Alpine. It's the simple web server to serve a file. Again, this is just defined by best practices. Except header. Okay, so this is what I'm saying, is that where you can get two formats for actually manipulating your data. There are actually now three for the retrieval of data. You can get GeoJSON, which is great because it means if you've got a GIS system or indeed anything you want to put a map on, then it's quite simple to push your information direct to your GIS because GeoJSON is a standard for geographic systems. And the fallback for any error situation is always going to be just application JSON, because as you can see from all the 3 examples above, they're all JSON or extensions of JSON. So therefore, error message, something goes wrong, we know that you should be able to accept JSON. If for some reason you put accept, I don't know, plain text, it will error because, of course, the whole API is all the payloads of the API are in JSON format. There are 2 NGSI formats. This normalized format, which I think is what I've done on the previous page. Yes, this normalized format, which is the one which has got the type property value or type relationship object format, is verbose but strict. Whereas the option key values gets you back the bit of JSON you actually want. So, you know, option key values is usable by users. Options normalized is if you want things like the metadata. You want to find out what the unit code, you want to look at the last observed at, you want to find out what the relationship of someone else is. Both of them have their uses, but don't think that FIWARE pushes you to use normalized at all times. Custom formats may be supported. It is possible if you're using Orion LD to request alternative X- formats, like give me back this in NGSI v2 format. So if you have an NGSI v2 service, like I don't know, take Cygnus, for example. Cygnus does data persistence, right? And maybe there are more data syncs which are covered by NGSI v2 than NGSI LD at the moment. Okay, fine, you could use this format to push the data out into other services which are expecting an NGSI v2 format. So don't use these for data exchange. For data exchange, when I'm talking about data exchange, I'm talking from my context broker behind my PEP, which is then talking to an iShare satellite, and their context broker with their PEP and their satellite. Don't use custom formats. Just use the standard formats. Right. So it is possible, if you go to the tutorials which I put on the put on the screen, you can actually follow along yourselves, and I'll get you to do this a bit later. But it is possible to retrieve information about the state of the world. That's the whole point of a context broker. You can either set or change the state of the world. If you're, you could have your digital twin, which is mimicking the state of the world. And you can see there are a series of parameters which should all make sense by now. Okay, so we have my context broker, which is on 1026, which is the standard port for Orion, /entities, which is, again, we're talking a standard REST API. And then we have a series of parameters like GRL, geometry coordinates, which are used for geofencing. These are well defined in the specifications. So you can say near a point or outside of a point or intersecting an area or what have you. Now, you'll notice that if you look at the coordinates line, the coordinates line has got this %5b, %5d. This is because it's actually square brackets, but your URL should be URL encoded, which it almost certainly will be if you're using any software library. But I've deliberately put that into my curl statement to explicitly show it, so I can say I'm looking for within near that point. On top of the geo filters, You can get filters by certain entity types. So in this case, we're getting animals. Or we could get even more filters using the Q parameter. The Q parameter is basically your query language. And this one, again, it should be readable. It's saying my species is pig and my reproductive count is in calf. So I'm finding pigs which are currently reproducing. Now, I said options key values makes sense. It's going to give us back data in a JSON format rather than the expanded normalized format. You've got here a tenant. As I said, I'm using OpenIoT. This would be my farm, right? And you can see here there's this prefer header as well, which means that because you've got application JSON and application LD plus JSON, and you haven't got Geo plus JSON and Geo plus LD plus JSON, you need to use the preferred header to say whether you want to have this at context element in the body or not. And you can obviously have the link header. And what would happen is you would get back a response in the following format. This is saying, we've already covered key value pairs. We've already covered normalized. We're now covering GeoJSON. You can see I just threw that response directly onto a simple GIS. I think it's called something like geojsonviewer.org or something like that. I can't remember what it is, but you can see it's got a feature collection consisting of a series of pigs, and each pig has got a series of properties. Now, those properties would just be your key values in an ordinary piece of JSON. It's just it's structured slightly differently so that you can get this nicely up on a map. Obviously, entities usually have a location. I mentioned location beforehand, and therefore can be plotted on a map. But if you have an entity like, I don't know, a shipping bill, which doesn't actually have a relevant location, location geometry would be null, which is perfectly valid for GeoJSON format. Obviously, you can't display that on a map. So why you'd want to do that in the first place, I don't know, but it is legal. You notice so far with all these examples, I'm just using the short names. All of my definition of my world, all these long mappings and what have you, I've got elsewhere in this at context file. So the answers should be readable and on screen. Beyond the basic operations I was talking about on Monday, and I'm going to show you this video in a second, I can also, with modern brokers, I think all three of them can now do at least the basic temporal operations, get more information about the history of an event, history of an entity. So I have an animal, and I want to find out the last 5 readings of that animal. I can use the /temporal/entities endpoint. They may not be supported by all brokers. If you have a look at the specification, it says that temporal could be on a different URL. You see this is on 8080 rather than 1026. It also might not be there. It's possible, obviously, for performance reasons. It's going to take, if you want to use a context broker to hold history, then you're going to have an awful lot of storage space. Obviously, tutorials do this, but they fall over after about 5 minutes because they haven't got sufficient storage space. Also, it slows the brokers down, because obviously not only do they need to do whatever they're currently doing, trying to collate entities, they need to do a push to databases. So it needs more memory to run. It needs and it requires performance. You can see that it's going to give you additional useful information. Sample doc and compose I'll show in a bit, but that's the link there. It's linked through the tutorials I showed you. Link I showed you earlier. So the response you would get, again, this is the verbose version. The normalized version is massively long, and unlimited temporal responses are very, very big. You can see here I have a series of animals with a legal ID, a name, a sex, and what have you. None of those attributes are being observed. All of those attributes are modified at, but they are other values. In this case, I've highlighted location and heart rate, where there is an observed at sub attribute, property of a property, sorry, and that is the basis of temporal operations. If you have an attribute which a property or relationship which has got a sub property called observed at, and it's just a string, it's just a ISO date string, as you can see on the right hand side, then you can use this normalized temporal interface to get useful information out. So in this particular case, and this is one of the examples of it was a possible training exercise, you can find out where my animal has been over the last 5-10 minutes. If you can work out where an animal has been over the last 5-10 minutes, you have a series of coordinates. It's relatively simple mathematics. Look up the Haversine formula to work out how far it has gone from each location to each next location. You therefore have got a pedometer for the animal. You can therefore work out how far an animal has moved. And if you can work out how far an animal has moved based on its heart rate and its phenological condition, you can then work out whether it's healthy or not. So we now have the basis for a simple monitoring system for animals, which could actually save the farmer money. Now you can see within these values on the right, you've got value, unit code, observed at. Unit code being the Ngsi fact short code for whatever the units are. For heart rate, if you look at the list, 5K means beats per minute. If you are looking at a location, obviously a location is unitless, therefore it hasn't got a unit code. So you've got various things which, because there's a well-known structure here, you can actually get hold of the information. But normalized temporal requests will get very long very quickly, so there are workarounds. You can find out information based on attributes which are not observed. So in this particular case, you look halfway down the screen, you've got the Q parameter is saying I'm after the female animals, sex equals female. And because that's an attribute which doesn't change, we don't have any trans cows in our system. We don't need to observe that regularly. So there's going to be no observed at element there. So we need to specify what our time property is for our query. The time property which would normally be used would be modified at, because again the specification mandates that context brokers keep a couple of system attributes with every record, one of which is modified at, the other one being created at. So you can always guarantee that there will be a modified at. Now, modified means a change in confidence of that value. So if I send a value 5, and then 30 seconds later I send the value 5, the value hasn't changed, but the confidence in that value has changed, because I know that 30 seconds later it's still 5, and that's why that's where the modified at would give you 2 records for that. Okay, so default temporal is observed at, but you can easily enough with the correct syntax And again, the tutorials show the examples on the syntax to say, oi, this is usable. The rest of it, as you can see, it's starting to get a little bit repetitive, because you know that it's going to have a link header, you know it's going to have a tenant if you're using a tenant. There are other parameters like pagination, page size, which will say, you know, just give me back 2 records or whatever. If you do use this time property and get modified, you'll get both modified at and observed at if it exists in your response. So you can see here my heart rate has got 2 values in there. I would recommend you use observed at if at all possible, because that's the one which is saying when the thing took place, because there may be a lag between the two. If I have I always use agriculture because it can be quite slow. If I have a LoRa network, let's say, and I have a reading from a soil sensor, which is only waking up once every 20 minutes, it could send stuff to my broker and say, the observation 20 minutes ago was this. It's not the observation right now. It's not the observation when the context broker receives it. It's the observation when it was taken in the real world. That's what observed at is, which obviously could be significantly different. Modified at is the is done internally within the broker, whereas observed at is done externally in the real world. So obviously it's more accurate to say, you know, this observation took place at that point in time, rather than this observation was changed in my context broker at that point in time. Pagination options. There are obviously, particularly even with slash entities, you can just get a count of entities. But with pagination, you might want to say get hold of the last n responses, or want to say give me back just the first 2 cows, or give me the first what have you, and so options count. Because the structure of the API, the response is always going to hold the data. It can't hold metadata about the response. So any additional information, like the range of times which are covered by my set of data, or the number of entities which match, total number of entities which match this response, or which page we're on for that matter, has to be pushed into a header. So you know that the body is always going to be structured in the same fashion, no matter which additional information you'd like to get back. But you can get back these additional pieces of information, like next page. So if I've got a page size of 2, and I put in cows 1 and 2 into there, and it says next page is cow 4, we can know where to start for the next query. You can see you can use this page anchor parameter to get hold of more information there afterwards. Please remember that context brokers are write time rather than necessarily real time. So it is possible that what we're observing right now might not be there when you next make your request. So it's possible to that things might be shifted based on your page anchor. But it'll tell, okay, we'll start with cow XYZ. There are additional parameters. Obviously, you don't just have to get the last 5 entries. You can get entries which have happened since a certain date. The timing there is that you need to have time rel, either before, between, or after. And obviously dates are always in the ISO date format, so easy enough to understand. You can see again, once again, if you look at the text at the top, I am adding in all the various things like the geo stuff and the which entities I'm after, and so on and so forth. These are all devices types, and I can also reduce the information I want to receive down to a certain number of attributes. Or obviously, it makes sense, given that these can be verbose entries, that I'm not going to get hold of literally anything for everything. Option temporal values here is the key values thing for entities. It reduces the amount of information you would get coming back. So yeah, temporal values, as you can see, compared to the normalized responses, is a lot shorter. So what you'd get is you get a device which says 61 at this point, 62 at this time, 63 at that time. You obviously don't need to know that it's beats per minute, because you've probably queried the entity beforehand to, in a normalized fashion, to find out what are the parameters of this. So this is great for pushing stuff onto a graph, for example. So yeah, or as you can see for the location, you can see you can also retrieve back a JSON object rather than a number. Typically observe that frequently it is numbers, but it can be a position, or it could even be a string. You can see that the controlled asset has got the for the smart data model device, there is an attribute called controlled asset, and controlled asset is what is this device being used for. So to read this using the smart data model, we're saying we have a device called pig collar, and it's currently attached to an entity called pig, which makes sense. These examples are relevant and worthwhile. Right, before we go into language maps, I can take a little break, because I can show you some of this live in action. So where's my video? Did I put that in the other one? History. That's not the one I need. Just a minute. I'll get my history. I'll see if I can. There we go. That's what we want. That's it. So, Key, can you wake up for a second and try, see if we can get your thing to work rather than mine? That will be my. Oops. Now. Right. Okay. So, Key, could you try running that that link I've just put in there?
Yep. It's just so tricky to copy in the chat, because.
Yeah, I know, but it means that my demos work.
Okay. Okay, let me share the screen first.
I stop sharing.
Imagine if you see this.
Yep. Let's start up the containers and see whether we can get something to run. Now, I've split my Docker Compose into two parts, because I want to make sure that the add-on is running before I'm starting. You can see, this is just the Mintaka component. You can see at the bottom half of the screen, I'm loading a timescale database. I've got some various standard attributes. Obviously, in any secure system, I wouldn't put my username and password in clear text, but you've got the idea. It's just something sitting on the web, and it's something I can access. Whatever username I'm putting into my system, I need to make sure that the Mintaka component has got the same name. So the same password is Orion, database is Orion, and it's a timescale. Now, the number of threads which you want to use, pool size, you could end up with starvation. So it's a good idea to make sure that you're not using too many threads at one time. I'm putting in information like endpoint info enabled, so I can actually do a health check. Say, are you up? Are you running?
and I need obviously that may or may not be sensitive. Now let's see if I can see if we're running yet. Oh, still provision devices. Okay. So we're going to wait for a short period whilst the thing's actually loading up. Obviously, it's creating the scenario I'm talking about. It's created 30 cows and pigs. It's linking devices. Obviously we have a device which is recording the heart rate, but also we want to have the heart rate on the cow. So we need to be able to push that information elsewhere. And now we're up and running. Right. Okay, so let's start off by looking at a device monitor. Yeah, farm is currently asleep. Let's start our tractor.
If there's any echo, it's on Key's side, not on mine. So maybe
we've now got various pigs and cows. They're all at rest because they start off inside the barn. But at some point, you can see that the animals will start, like pig 2 is currently foraging. They'll start changing their status. You will find that the location is moving slowly, and obviously I've got quite a large cow. You can see all the pigs are coming through at the moment. Now this is difficult to see on with raw data coming through. So let's see what happens when I actually make some requests using my context broker. So I'll do the last 3 entities here. Params, that's right. So let's see if animal 2 has got some data in the system. It will take a little bit of time to begin with, because obviously, like any NGSI LD system, it doesn't know initially what the context is. So it's going to have to download the context data, which is, we've got it here. Where are we? I've got it here. Where's my context data? Yeah, you can see it's going to have to download my context. And this has got all this information. It's in a well-known location. It takes a bit of time to process that. It does that once, of course. It then would purely cache that, and then next time I'm asking for the same context, it doesn't have to do it again. Because of the nature of JSON LD, you could, in theory, have all this embedded inside your requests. So it gets rather complex, but the best way to do it, and indeed, if I show you the other thing here, is to have, say, a web server, like in this case it's Alpine, which is just serving that file from a well-known public location, and it's within this system it's known as context. So you can just get hold of it. Now, again, looking at the Orion part of this, because this is split with an add-on. You can see here again we have the environment variables, which are saying, okay, I want to persist my data into a timescale database, and these are my username and password, which obviously shouldn't be in plain text, but you know what I'm talking about. It is worthwhile mentioning that normally when I'm doing my demos, I would leave the log level at debug. But of course, this is getting a bit more memory intensive. I've only got a small machine I'm running. Things can slow down quite quickly. So I've changed the debug level to error. It's not really.
Okay. You stop the video for a second. Right. Given that we're getting a lot of echo, it's probably going to make more sense if you just watch this section of the video yourself. Rather than get the echo in the background, because it's not helping at all, is it? So what I suggest we do is, if you we'll take a little break for this bit. If you go to the following URL and then just play the video for 5 minutes, it will cover this, and you'll be able to understand and hear it and get it clearer. Because if the video quality is not working for us, then it makes more sense to do that. So what I suggest we do is you just break out for 10 minutes. I'll let you watch the video, and then we'll come back again. Does that make more sense? Because it's going to be better that way, isn't it? Yeah, I'm getting some thumbs up. Okay, so you've got the link there. If you're a good student, you'll spend some time looking at that video whilst we're taking a 10-minute break. and then we'll come back at past and continue there afterwards. Okay.
All right. I hope that you guys have a great break. Jason, are you ready?
Yes, which didn't help. So you can start up again. So I can put my presentation on. Share screen. Right, we should be back now. That was excellent timing because the internet went down here for absolutely no reason whatsoever. So I completely got kicked out. So it's quite good that we come back when we did. We've already got a question in the chat. I like questions. Is this temporal API recommended for historical query of IoT devices, or is it preferred another way of doing it? If you look at the full length of that video, I think it's that video. Yes, it is that one. There is a full section right at the end is for quantum leap versus temporal interfaces. There are two ways you can do this. One is to use the temporal API. One is to use a backing database or a persistent data which has been pushed into a database. Both of them have their uses depending on what you're trying to do. In the example I was giving is, imagine I just want to put the graph of the heart rate of the animal on a screen. You can use something like Quantum Leap. You can put that straight onto Grafana. There is an example, show you a point to another video where I'm doing that, and that works perfectly well, and that's perfectly usable, and it's really simple. However, if you are in a situation where you want to get data from multiple context brokers and you want to mix the data between disparate sources, say, for example, you want to do a data lake scenario. I'm a consortium of farms, and I'm getting data from multiple farms to try and find out what's the overall status of our animals. Then, because you are in a situation where you want to be federating your data, you will be pushing the data. Putting the data from the interface, because it's the only way to make it work sensibly. I'm going to try sharing my screen again so you can see me, because I'm not hiding. There we go. Just scratch my nose. If for some reason my
should we answer another question just to make
sure? Yeah, sure. We can answer the questions whilst they're coming through. Can observe that be a timed interval? No. Observe that by definition is a timestamp. So it defined within the API. Question to ask you is, why do you want a time interval for an observed at? There are advanced temporal operations, which I haven't got time to cover literally everything here, where you could actually start doing things like give me the aggregate of values between this. You've got some nice stuff there. Aggregate of values between a certain period of time. So you can say, I want to find out what's the average over each minute between X, Y, and Z. Not well supported across context brokers at the moment, defined in the specifications, so it's doable. Again, I think same video. If you look at the beginning, that video is all about temporal. So you'll find out more information there. Now, this is this is a good advanced question, so we might as well spend some time on it. I've had a look at the ISO XML specification, and a method of trying to place timings across in this case, it's where you would place seeds along a location where you're planting stuff, where you've got times associated with the GPS, which hopefully is the same thing. And Gary on can probably tell me I'm all wrong, but put it in the chat when I'm all wrong. Now, if you want to do something really advanced, like you say, okay, I'm observing this value at this point, and this point, and this point, and this point, and then I want to get what the average of that value is onto those points. The way I would do that is via post-processing, because it's a case that the specification says observe that does this, so observe that does this. You can't use observe that for it. For the usability of your data, you want to associate a property of a property, metadata, with your GPS location, so your average. Now, there is a component called Cosmos, which actually originally was a stream data processing component. Is now it's a series of connectors to things like Apache Flink, which could actually get hold of that information. So what you can do is you can set up a subscription to listen to your value. You can do the processing, and you can. There are also syncs from Cosmos back into the context broker, so you can annotate the record to say the average is such and such. So you would then have, again, the way I would probably do it, I would take the initial entity and call that the raw data. I would then clean it or modify it and have a separate entity with the clean data and the metadata inside it, and use that going forward, because it's a good way of getting rid of anomalous values, for example. It is a really rather advanced way of doing it, in that you have, if you think about it, your entity data is the state of the real world right now, right? That's not always what you want. What you actually might want is information of, what was the average of the last 5 minutes? In which case, easiest way to do that is to represent as two separate entities, raw entity or processed entity. Another way you can do it sometimes, and I've seen it done before, is if you have IoT devices at the edge which have got sufficient power that they can actually do some processing, you do the processing before you push to the context broker. So you've got the average elsewhere. A third way of doing it would be to have a series of context brokers. You have a context broker at the edge, which has got the raw values, and then you have another context broker in the cloud, which has got your cleaned up data. So yeah, you're talking about really nice advanced stuff. If you want to ping me on the LinkedIn, we can discuss the various options in more detail. But yeah, this is the sort of thing which I kind of expected would be people ask me nasty questions here on the advanced programming. So any further questions before I move on to language maps is the next section? I assume that I'm not getting any further questions, so let's move on to language maps. Again, what I'm covering. There we go. So anything else coming up? Right. Could I copy / send the historic values of another file so I can work with those saved values, or is it no? Ha ha! For example, I want to save to. All right. We have. All right. The answer to most of these questions, if I go to video, The answer to most of your questions can be found on our webinar courses, because obviously we've been covering a lot of different ways of getting data into FIWARE. Now, specifically for that one, where is it? It's going to be, there we go. Specifically for your question, the video you want to be looking at is customizing IoT agents. When you have, and this was actually more the subject which I was going to cover on Thursday, but I'll do briefly here. When you have data in a context broker, it needs to be pushed in there somehow. So you can consider an IoT device as a source of context data. However, you could just as easily say, okay, I've got this file and I'm pushing it to some service, and that's my source of context data. You know, it's got the values, the cleaned up values, the temperature values, whatever, for multiple entities. And it's what's, if you look at the Ngsi specification, it's what's called a context producer. You know, it's a source of context. And we don't care where it lies in the real world. The whole idea about having IoT agents, again, we'll cover IoT agents later, is that we're abstracting out what the actual IoT devices are doing. So yeah, you can just get hold of this data direct from a file. You can tidy it up and then push it into your context broker once it's tidy. So this may also be a way of doing Gerion's problem. There's always a way around these through architecting it properly, because as far as I'm concerned, technical evangelist in FIWARE, is that data gets into a context broker. The further you get away from that, the less it is directly what I'm doing, the more it's the associated elements like your IoT devices or your AI algorithms or your graphical display interfaces or what have you. They are one step further away. So you need to get the data into the system, processed, and then pushed back out again, and then you can use it in the fashion you're after. Right. Any more questions on that section, or shall I move on? I'll just have a quick look at the QA. I think we're done. Okay, we can get moving. That was a nice 15-minute break. Seriously, folks, that is precisely what you should be using this week for. If you've got questions, I will attempt to answer them. If you have got questions which I can't answer directly, then obviously I'll need to contact you, maybe talk about it later. But obviously, anything you're doing so far is likely to be of use to the entire group. So now I'm just going to go on. I said I was going to do advanced operations. This is additional stuff which has been put into the Ngsi specification 151, the latest version. If you wonder why they've always got this 1 at the end, is that 150 or 150 is always the one which goes for approval, and 151 is the one which has been approved by Ngsi itself. So that's why it's got the 151 at the end. So it's basically it's 1.5. And then one of the concepts which you've got in there, which is particularly useful for smart tourism, but also for any multilingual situation, is language maps. If you look at JSON LD, JSON LD has got a series of operators. So, for example, at value means that you've got the literal value of something. At type is the same as the NGSI LD type. At ID is the same as the NGSI JSON ID. It's the unique identifier. All these are defined in the JSON LD specification. There are a couple of additional operators which are being added into the specification. One which is has been formally added is at language. At language is language maps. So as you can see highlighted on the right hand side of the screen, you may have a simple string where you have multiple valid names for that simple string. In this case, you're talking about the middle of Brussels. You've got the great big square in the middle of Brussels is called Grand Place or Grote Markt, depending on whether you're speaking in Dutch or you're speaking in French. These are equally valid. Now, if you, at the moment, I would suggest that you would just use an object for this, but there are additional advantages when you're using the query language Q parameter to be able to define this stuff as multi-language and then retrieve it as multi-language. It means that it is possible if you add in the lang parameter to say I want to retrieve values in a certain language. So I can say I want to retrieve my language in English only. Or again, you look at these various different ways of doing things. You can have any language star, which is what should be used as a fallback anyway, according to the HTTP specification. No, it's the IETF specifications. Strictly, if you ask for English, you don't have it, should 404, but no one ever does that. It just defaults to whatever we've got. But you can then follow the language parameter saying I want Swiss French or French, or you can have I would prefer this language over that language, and if you've got nothing else, give us the following. This syntax is already in use in your browser. If your browser is responding to you in Spanish, then it's probably because you have got your preferences set up as saying I prefer this in Spanish, and obviously not all websites are in Spanish, so it does its best to try and cover this. What this is useful for is that it means that you are able to retrieve values, and you can see here on the right hand side this is a normalized value to say I will get the street back as Grand Place and it's in French, language FR. However, if you do the same query and you ask for key values, it will just return Grand Place, which means that context brokers are able to speak French, basically. So it's by adding in a lang parameter to your gets, you can say, give me the attribute which is set up as necessary. Language maps are limited to simple strings. So you can only change strings in JSON LD to be marked up as languages. Therefore, if you want to expand to entities which are in multiple languages, so for example, this is saying we have an event called Bonjour le Monde, which is in French, then the recommended way, according to the annex the Ngsi specification, is to use schema.org in language or an equivalent. There are already well-defined IRIs which will say how to mark up an event in multiple ways. Obviously, if you're in a monolingual country, then in language doesn't make sense for the vast majority of data models. But adding in language as a well-known additional attribute is not going to adversely impact the usability of the data. It's just saying, you know, I've got this additional attribute. I don't know what in language is. Oh, it's a schema.org in language. I might be able to use it, but otherwise, you know, you've got the information in there. You can see that in language does not necessarily have to be placed at the attribute level, the lowest level. It could be a property of a property. So in this particular case, we've got the same event in English, French, and German, and you can tell that Hallo Welt is in German because it is the same as Hallo Welt in German. It's the same as Hello World in English. The same as Bonjour le Monde in French. It means that your models are not any different. There's no such thing as a French event. It's an event which happens to have an attribute which says I am running in French. Expansion and compaction is, again, not strictly speaking an NGSI function. It's a JSON LD function, and it is possible when you retrieve data out in a JSON format, such as NGSI LD, then it is possible to modify that data. If you go over to the JSON LD playground, which I'll put the link in here. Oops. She knows. If you go over to the JSON LD program and just put the you can actually manipulate your data. Your data can you can use as I showed yesterday. I was able to get my data out in Japanese. Now there are multiple libraries which can be used to do this, so you don't have to worry about it too much. But this is really, really, really useful in that if you have data from this external source and it needs some sort of minor modifications, then just do expand, compact, and you get the data out in the format you're able to use. Usability outside the usable format is always what we call key value pairs. The data transfer is the normalized format, so you can actually run this properly on your data, and it can come out as necessary. That's a very what I've got up on screen is a very simple Node.js function. You could do it just as easily in Java, Python, C++, whatever language you like. You know, there are multiple libraries out there. I believe that they're all linked on the JSON LD GitHub as well. So yeah, that was the example I gave yesterday, where all of these attribute names, which because we are agreeing on our IRIs, can be changed from one representation to another. And all of you Japanese speakers out there will understand what's going on, but no one else will. You will notice that value for the address, the sub attributes have not been changed. And the reason why the sub attributes have not been changed is not because I'm lazy. It's because I have defined the address as a schema.org address. And a schema.org address always has attributes called address locality, address region, postal code, and street address, amongst others. So therefore, I'm not going to override those with as a schema.org address with something else. I could, of course, manipulate it going further. And as you'll probably realize, because it's no longer got an ID or a type or a location for where the location is, the representation on the right is not a valid NGSI LD representation. It is still, it's not even, it hasn't got an at context anyway, so it's still JSON, but it's not JSON LD, it's not NGSI LD. It's for use by your application. If your application wants stuff in Japanese, your application wants stuff in Japanese. Give it to me in Japanese. I don't care. It's not necessarily going to be changing language. It's going to be changing the names and the attributes. So if you happen to be calling something temp and I'm calling it temperature, that's when you do the proper manipulation. It's just that I used Japanese in this example to make it very clear on screen what's going on. A context broker is not a panacea. Don't expect context brokers to not do context broker things. So it is difficult to, say, get dates out in French, because there's never going to be an attribute for observe that in French. It needs to be manipulated. She knows. It needs to be manipulated in your side. It's nothing to do with the data models. The data models will assume that all strings are Unicode strings, all dates are ISO dates, All numbers are numbers. They can be floats or they can be integers, and you can use any JSON primitive or JSON object for your stuff. Now, this means that it's a lot more difficult to actually get hold of certain bits of information if you are not a computer. It's designed for data exchange. It's designed for computers. So if you want to get hold of additional information, and let's say you want to sort your streets in Spanish, which doesn't care about accents, the best way to do that would be to add in additional properties like a collate value, which holds the same data but modified. So you can really itchy nose, scratch your nose. That's better. So you can replace all the accents using that little bit of text there, which is NFD format is basically usual standard ASCII stuff. And it says replace anything which is in the Unicode range, put everything lowercase. Right, now we've got something we can use to sort our list. So we can then make queries on everything in really bad the sort of Spanish other, right, with no accents and everything lowercase. Great, makes life a lot easier. Similarly, if you want to specifically get data out in a format, I reckon that getting your data out and displaying it is not our business. It's your business, but not our business. So you should be doing this on the receiving end and then modify it thereafter. Obviously, you can't push a French date into the system because it's not a valid ISO date, but you could actually quite nicely display it with, vendredi or whatever it is on the on screen. Similar sort of thing can happen with another reason why this isn't in the context brokers is it is totally cultural. In Spanish you ignore accents, but in German you consider something with an umlaut over it as being two letters, or an SZ is considered is spelled as if it's double S, which is the same way the Swiss would do it. So it will depend on what your market is as to how you need to localize as necessary. If absolutely necessary, you can just throw this into a property of a property such as a collation attribute. Indeed, if you look at databases claim to be able to sort stuff according to natural language using collation, and the only reason why they do this is because they are doing the same thing behind the scenes. So basically saying, if you need to do this, it's your problem, and this is how you can deal with it. Other context broker anti-patterns. Don't do this. Don't do this. Context brokers hold a snapshot of the real world. So you can't store images. You can't store, what's going to happen next. What's going to happen in 5 minutes? Is it likely that my car park is going to be full? You can't do that directly with a context broker. What you can do is you can say, for example, if you've got a blob type, binary type, you can store that like an image on something like S3, Amazon, whatever, and then have a link to that as your attribute. Obviously, the link will change. If you want to find out, what's the likely prediction for the 5 minutes time, then you can have an attribute saying, short-term prediction, go for this URL. You can, of course, add in additional attributes once you've calculated this sort of thing. This is actually the way that I believe. If you look at the list of webinars, there's one on ML Ops, which is the way they're doing. They're saying, okay, this is how this model is currently functioning, and then you can use that to work out whether the machine learning has actually learned something, because it will slowly drift from reality if you're not careful. But typically, if necessary, you need to use other data storages. You need to use databases as databases, or you can actually have some external job which will then push data back into the system. But in the main, you should consider your context data is just context data. Okay, filtering. Again, we very briefly touched this when we were looking at the basic operations, but there are lots of ways you can cut down your data. We don't necessarily need to get an entire entity or all the data from an entity all the time. So in this case, you are looking at just getting a certain type of entity. Well, there is a type attribute filter, so you can just get shelves. Similarly, you can just get a certain number of attributes from your data, and indeed, the ID should be unique within your federation. Now, I said within your federation. If you have data from an external system, they hopefully won't, but they may be using the same IDs as you are. So you may need to have a well-defined legal ID, let's say, for making sure that the entities are held in common. Ideally, if there is something out there, it's got a unique ID. That's what the IDs are there for. But you can't guarantee it. So you may need additional fields in your entity to say, okay, the legal ID of this animal is such and such. Because in the situation, and I give an example of, let's say you've got a vet and you've got a farmer, you want to make sure that they are both talking about the same animal. If you can't guarantee the same ID, you can guarantee, because they're using the same data model, that the legal ID of the animal is cow 1, 2, 3, 4. In which case you can use that instead. Each of the parameters I've got on the screen can be filtered. You can have multiple IDs, multiple types, multiple letters. Just comma separate them, not difficult. And it pointed out the difference between key values and normalized. I've done that already, so I need to mention that again. Key parameter, as I said, is very, very powerful. You can add in multiple clauses to your query as necessary. So you have the 12, is it? No, well, 6, 7, 8, but whatever. You can read the number of different things: equals, unequals, greater than, less than, etc., etc., etc. And of course, you can and or these things. So the first one is looking for speed being greater than 50 with revolutions per minute greater than 3,000, and the brand name is Mercedes. Obviously, you could make multiple queries to do this, but it's easier to just reduce them down. You can see, if you look at the one at the bottom category, it's looking for stuff in an array. So it's possible to look at stuff inside an array to try and find out what's going on. For the city, as you can see, the value Düsseldorf has been URL encoded, because internally the string is going to be a UTF-8 string, isn't it? So it's going to be the normal stuff. Not difficult, as I said. Your library will URL encode this stuff, so it's not a problem. Dot gives you a range. That's another one which is useful. Depending on the use case, what you're trying to get back here, but obviously the idea behind your filtering is to just reduce it to whatever you're actually interested in. This is the list of the stuff you can do with the GeoQ parameters. You'll notice that there's an overlap between GeoQ and the temporal, which I think I'll repeat briefly. There are geometry. I don't think that's actually strictly speaking correct. Geometry is any supported GeoJSON type. Context brokers themselves do not support feature or feature collection as types. I've never seen any use of multi polygon, but I suppose it's theoretically possible. So you can find the geometry to then work out what the centroid is or what the position it is. Every GeoJSON type has got a coordinates, which could of course be an array of arrays, like the polygon example below, and it could be that you're doing a geoproperty on something which isn't called location. The reason why you've got geoproperty location at the bottom is that it's optional. You don't actually need it if you're talking location, which is why every smart data model has got a location called location, because it makes life easier. But you could easily imagine a situation where you've got a start point and end point, and you might want to do something on one or the other. Fairly obvious geo relationships: near, within, beyond, inside, outside, or equals is not particularly useful, to be honest. But it's intersect is much more useful, because obviously there's going to be a bit of jitter within your values. Temporal parameters, isn't it? Temporal parameters, as I've said, you can see there's a lot of overlap between the style we've got for the GeoQ and the temporal Q. State ranges. There are now additional duration options, but that, as I said, that's the in the latest specification. So you've got before or after or between. Similar to observed at. Similar to location, observed at is the default property for temporal, and you can supply another one if necessary. Right, now we move on to the next section. I suggest we take another short break. I'm just going to get myself another cup of coffee, and I'll move on to connecting data providers, which is the meat of the i4Trust experiments. So those of you who are still awake, go off and get a coffee. Let's come back in 5 minutes. Right. Right. We're going to cover connecting the data, but one of the things I'd like to do before we finish this evening is to see how many of you can actually get a FIWARE system up and running. Now, last break, when you were watching the video, you were seeing me making various connections to a system and querying some temporal information. Now, the actual Git repo is this one here. I'll just put in the chat. Sorry, I'm putting the chat, put the right one. And it would be good if, in the background, whilst I'm talking to you for the next 20 minutes, you start downloading the system and see if you can get it to run. Now, it should be sufficient to run the following commands. I'll put this in the chat. And then you can get the thing up and running by, is that the right one? Was it short-term history? Just by running services start, which should be, let's put this in the chat, services start. Right. In approximately an hour's time, I'm going to, again, take another break, and I will sit out the tables so that anyone who's got who wants to work out, I haven't got my system running, blah blah blah. I can actually go to individuals to try and get it working. So that's something you can download in the background whilst I'm talking about connecting data providers. Okay, so we're back on my farm, and this is a typical scenario we're trying to cover for i4Trust, where you have multiple sources of data coming from multiple context brokers, which are owned by different entities. If you can consider your existing experiment and work out who owns the data in each area, you can see that there should be the case, because you've been funded as a project, there should be the case that it can be clear that there are different data owners here who are doing a data sharing scenario. That's what we're all about. So in this particular case, imagine the following scenario. A farm has pigs and cows tracked by animal collars. Veterinary practice holds status records for the same pigs and cows, as I said, this legal ID idea. And the weather service is providing detailed conditions of locations on the farm. You can see there are three separate sources of data here, but you can also should consider which ones are the ones which I, as the farmer, can actually produce or own, which ones are the ones I should I need to get from elsewhere, and also which common data models need to be used. Now, because FIWARE is part of the Smart Data Models Initiative, and they are covering areas such as smart cities and agriculture, they would be a good choice for looking for the common data models in this case. It could be the case that your domain has got certain standards. I don't know what they are, but you can tell me what they are, and you can get the data models in that area. And the one which I always go to is, if you look at GS1, for example, they have various data models around cheeses, and you can work out how hard or soft or runny your cheese is based on their data models. Now, not necessarily relevant to a smart city, but really rather useful for supermarkets. So, each one of these gets the information coming up then in their own area. So in this particular case, if you're thinking about it, right, okay, what data does the farmer own and produce? What models should be used, and how can we get the ensure that data from my broker is separate from your broker, and therefore we need to make sure that we have to have some sort of common way of looking at this. Now, it's fairly obvious if you looked at the scenario I've used beforehand, that it maps very nicely onto a series of well-defined data models. Go over to Smart Data Models, just type in whatever random word makes sense in your scenario. You will be directed towards the right sort of entities. So obviously, there is no real difference between a pig and a cow as far as the amount of data I can get hold of. They may have additional attributes, but they have a lot of commonality to them. So I'm going to use the animal data model, obviously, in this scenario. Similarly, I have cows going around the various fields. The field is an agri-parcel. It's a part of land. The animals themselves don't have data. They have data provided by devices like animal collars or ear tags or what have you. So therefore, I would need devices in this scenario, and the cross-environmental. There are a series of cross-domain smart data models, and obviously, weather observed is one which makes just as much sense in tourism as it does in cities, as it does in agriculture. That would be a good basis for the data. Now, you can tell again that the data the farmer has, they've got animals, but the vet also has animals. Similarly, the data the farmer wants and is paying for or getting from elsewhere is this weather observed, coming from the weather service. And you can see that they would be providing in their context, hey, I am offering entities of type weather observed with this following long URL, so that we know the format of that data. And this way we can start doing this data sharing working properly. So in this particular case, we have got a cow called Twilight, cow 6. And I'm just saying, look, in my particular case, I've not been able to align my IDs of my entities properly. It'd be nice if I could, if they could have a unique value, but within the farms data, let's say the vet was set up 20 years ago. The farm's new. They've got different systems. We can't agree on the IDs, but we can at least agree on the legal ID. There's going to be some sort of key to recognise that this cow is Twilight, as opposed to being some other cow. Now we can have this as there must be some sort of globally shared ID. Ideally, it is the ID, which is the ID, but in this case, it's going to be the legal ID. You can see there are certain bits of data which I'm going to end up copying in from my third party. In this case, we're going to get hold of the reproductive state of the cow, and on the other case, I'm getting data in from my weather forecast. Now I'm talking about a cow. A cow is placed in a field, but the field itself has got some sort of weather forecast. The cow isn't raining. It's the weather conditions that they're located at of the cow. Now, because it is more convenient for my processing, for my system, that I want to get a hold of animals. I don't want to continually move from one record to another. I am also getting hold of the information in both. I'm copying over the information from field 001 into my cow record, because that way I can do some AI processing or whatever. Convenient. The agri-parcel entity obviously needs to have sufficient information to be able to request the weather condition, and how we pull in this data is what we're going to cover next. So think here, what are my data models, and then how do I use the data? And they might not be the same thing, because obviously a cow is never raining, but it's useful to be able to understand what the weather conditions, where the cow is currently located at. Now, notice again, the cow is currently located in field 001. The cow could move. They're located at, which is what part of the standard model is a status of the cow itself, saying I'm currently in field 1, and therefore it is legitimate to be as an attribute. And then you can put the additional data in as properties of properties if that is necessary. So in this particular case, we'll start off going back to getting hold of whether my cow's in calf or not, my vet bills. What I can do is I can subscribe to changes of data. So I can say, "Oi, vet, tell me when your the status of Twilight has changed so that she's now in calf," and we can then do a pull if necessary. So what I'm saying here is when the reproductive condition of the animal has changed in the vet's data, it should raise a subscription, and it should give me back the legal ID of the animal, and it should also say, what's the necessary URL or whatever to be able to refresh my my vet data. It's an additional attribute, and we can use that to make the GET request to get hold of additional stuff from the context broker. The additional business logic to manipulate the response means that you could get hold of the data thereafter. As usual, there is always a context in both of these systems. So yeah, I could alternatively, I could say, okay, I have a field. The field has a related source, which is some additional application. In this case, it's an external weather application. And I can use this related information, which I have got inside my my system, to then go off and make additional queries. So the related source attribute, again, related sources is part of the standard agriparser model. So we're not, we're not extending the models. We're just using the models properly, and we can say, okay, this has got this application, so we can or get the weather conditions for that particular agriparcel. At that point, I think the next slide is it. Yeah, external data. Okay, so you can see that in this particular case, we know a related source is saying we can get related information from this URN, this ID. This isn't doing the legal ID, it's saying get hold of the information where it's called the related source. So it's got sufficient information in here to be able to get hold of the weather conditions. At this point, as you can see, because I can get from my field the fact that this is actually AgriApp 101, I can then make a request over there to say update my values. It's a patch. The patch is saying modify the real world. Modify the real world is saying, oi, go off and get my data. In the case of devices, it would be like, oi, go and switch on my my lamp, whatever. How that works externally is that you would have a registration, which would, or in this case, a subscription, which would listen into that changes, then do the pull. There are basically two ways you can do this. You can either do a subscription, listening for changes on that outage update. Then you get your microservice, which would then say, I need to go off and pull my data or switch on my lamp or what have you. Or you can do a registration, which is saying, okay, for this particular patch, it's going to be dealt with by an entity over there, sorry, a context broker endpoint over there, and then it would forward the request to the other endpoint, in this case, the weather app, to get hold of the additional information. So in this case, I'm saying I can subscribe. I can subscribe to changes on an attribute to trigger a refresh of data. So you've got to think, how can I get a change made in the system? Well, at some point, the vet or the weather forecast needs to be informed, or a proxy service for that weather forecast needs to be informed. So you get you need additional business logic to cascade the result back. Now, going back to my cow, I want to eventually get my weather conditions into my cows. So having made a request to the other context broker to say, give me the weather forecast, I will retrieve that data. Again, you would need your own business logic to say, well, okay, when I get back a weather forecast for associated with field 1, update all the animal entities which have got that field 1 as a as an attribute. This goes back to the Q parameter. You look at the Q parameter, you can iterate through the ID, or rather you can get the IDs of the element. You can go through the Q parameter, and then you get hold of the because you know the existing field, you can then update the field. Just get back here again. Yeah, not that one. Yeah, located at. So we know this value. We know that it's field 1, which has been updated. Therefore, we can update that located at attribute in its entirety, putting in the located at with the same data, the type and the relationship is the same as beforehand, but the weather conditions would change from raining to sunny or whatever the various values are. So you can see how you can then pull in the data in from elsewhere, and you've still got it in a generic format. Now, again, once more, back here, as I said, the cow is not raining. So if you were to get the cow entity in key values format, it would just say it's located in field 1. However, if you want to do further manipulation, that is when and make further guesses about what's going on, then you'd need to be returning back in normalized with the sub attributes in order to get the data coming back. Okay, so usable or ontologically correct? The answer is usable. Strictly speaking, an animal has no weather conditions. I think we can all agree that cows don't rain. But you need to be able to navigate the knowledge graph. And there is nothing wrong in a context broker in duplicating your data. We're not talking about a database here. If you're trying to use a context broker as just a database, you should be using a database. So trying to go to third normal form for your data is absolutely stupid for context brokers. Context brokers, an entity is an entity. An entity is a thing in the real world, typically. If you want to go further than that, you can, but you don't necessarily need to break things down to saying, I have a device which has a readings, which is a reading value, which is a reading property, and what have you. No, there is a tendency to use a very flat hierarchy, and the advantage of this very flat hierarchy is that I can find out all the information I need to know about cows by requesting my animal, and that's how you should set it up. You're not changing the data model. You're not adding in stupid stuff like weather into the cow data model, because it's a property of a property. However, you've got sufficient information in there to be able to get hold of the data. Now, obviously, the more you put in, the more specialized you get, the less interoperable your data is. However, you can reuse common names to make sure that it's clear. Always imagine that someone else is wanting to use your data. So if you've got a value like weather conditions, it should be one of the attributes which already exists in schema.org, one of the attributes already exists in the smart data models, because then it is much more likely that a third party who eventually gets hold of your data will be able to understand what's going on. Right, registrations. Registrations, upset registration. Okay, no, first line is different. Upsert. This is going back to the question which came about half an hour ago, which was on CSV, push model from devices. And it can be a push model from the third parties as well, for that matter. Typically, you could have a device in a field. It will push data saying, it is currently wet, it is currently sunny or whatever, and it will push data as a context provider into a context broker. You could have an external. It could be that your vet application every day pushes your data into your system. This is just using a posting upsert. If you are letting the vet update the farmer's records, then you have to be certain that the vet is who the vet says they are, and this is where your iShare stuff comes in, and your key rock and what have you, to make sure that they are only updating the bits which they are allowed to do. So they might be able to update the state of the cow, but they wouldn't be able to update the prices of the meat, for example. That is very common, that you are gaining data from a third party. You can also use registrations to do this. Registrations can be used to either federated environments or actuations, but not both. The current Ngsi specification is clarifying this in that federated environments are going to be called what's known as inclusive registrations. A federated environment is going to be the case where I know something about the entity, you know something about the same entity, and we can get everything together to be able to make a better decision about it. So if I know certain things, or let's say we both know about the speed of an entity, yours might be through GPS, mine might be through some sort of triangulation method. We can put both of those values into the response of the entity to give an indication of you think it's going at 30 miles an hour, I think it's going at 35, whatever. Now, the opposite of this is what's going to be known as technically as an exclusive registration, which is saying the data for this value comes from elsewhere. And that is currently the way that IoT devices work. If you can have an IoT device where I say, okay, if I do a patch onto my IoT device, I will change the state of that IoT device. The state of the IoT device is actually a change of state in the real world, and therefore it's being dealt with, somewhere on the edge, rather than in the context broker in the cloud. As far as the user of the context broker is concerned, it makes no difference. They're still doing a patch directly to the context broker. It's just the effect is to change the real world rather than just the digital twin. Subscriptions can be also used for actuation. So you could have a situation where you are defining your digital twin in your context broker, and it's changing a virtual representation of your entity, but there's a subscription on the various attributes of that entity, which then go off and do something in the real world. So all of these are possible. Which one you should use will depend on your use case, and it's going to typically, as I said, typically IT devices have tended to use the registration method, although I've seen the subscription method as well. Typically, when you're talking about read-only, you can get away with just doing the upsert, because the advantage of the upsert is that you don't need another component which needs to be able to receive anything from the context broker. It's just a push, just data going into the system. So that was the final bit of that presentation. However, we've got another 20 minutes, half an hour to actually see how the how you're getting on with getting through some of the tutorials. So what I suggest we do is I will again finish the main presentation here. We won't finish the live session, but there are a series of tables which are available directly from the AirMeet, and I can go in and help you one after another for those tables. But before we go, good thing here. Any questions Q&A which are useful for the entire group, we'll deal with those before we finish the system. Now, unfortunately, I won't be able to answer that one because I don't do iShare. You'll have to wait until a later session to get an authoritative answer on iShare. I believe Dennis's session, which is on Friday, is probably the best one to ask that question. So you can ask me questions. I can say I don't know.
Yeah, so they are on the same hours on Friday. We have a section that have iShare CTO and CEO will present, and you is the best place for you to answer.
Yeah, I mean, the title of this session is Advanced NGSI Operations, and I'm very much trying to focus on the NGSI. Working solution regarding iShare. Don't take my word for it, but I believe it's the case that the existing Happy Pets system is available on GitHub. If not, you can talk to Dennis to work out where it is. I personally have played with the Wilmapet proxy to do some basic iShare operations. So it won't do things like validate your iShare satellite, but it will check the JWT token to say, yeah, this according to the encoded JWT token, they've got another 20 minutes to use the data. Therefore, I don't need to go off and do the authorization or whatever. So there are lumps of code out there which will do what you're after. So do we have any further questions for the broader audience, or do we scatter down to the tables where I come in and ask you individually, why can't you get my tutorial working?
Or you can ask Jason directly in the table.
You can ask me in the tables. The advantages of doing it now, of course, is if there's general questions. But if not, what I suggest we'll do is, again, we'll break. We'll go directly. I'll go directly to the tables. I'll start with table 1, table 2, table 3. So if actually before I go, or before we go, have any of you managed to get any of the tutorial working? If so, could you indicate with the emojis at all? So the absolute silence seems to be that no one's got anything working, which is a good start.
But the thing is, no one can speak, so.
No, I said they can push the emojis. They can the reactions button. So so someone's actually done some of this already. There's at least one reaction there. If you want to get some of this started, I mean, one of the suggestions was that we should try and do a session 0 on some of this. I'll just start coming around the tables and see who's there, who wants to get some help. We've got at least someone else coming in there. Okay, so let's. I said let's stop the video bit now and actually do the proper tutorial mentoring-y bit. So kick me out, and I'll try and join table 1.
Well, should I end the section completely?
Pause this session.
Okay.
Pause this session. We'll go to the tables, and then I'll probably end up doing a short wrap up right at the very end, but we might or might not need it.
Okay. Yep.
If there's some general questions coming out, I can actually start mention that as well. Okay.
Okay. So see you on the table.
See you at the tables.